Hello dear students, in today's video we are going to discuss about chemical reactions and equations. We already started the lesson, and with the previous video we discussed about what is chemical reaction, what is chemical change. Chemical change. So a chemical change in which a substance changes itself into another substance due to external agencies like heat. Say every chemical reactions we can say chemical change is happening. So milk turns to curd, so and so. And yesterday we also discussed about how can we represent these chemical reactions. We can represent chemical reaction in the form of word equations, in the form of chemical equations, using the symbols and formulas of the compounds of form U. Here again we discussed about skeletal equation. What do you mean by skeletal equation? The equation in which both the left hand side and the right hand side is not balanced. So such an equation is known as skeletal equation. It's only for the informative purpose only. So when we write the equations in balance in a form of word equation, so we require only the names of the elements or compounds that are taking part in the chemical reaction or the products which are being formed as a result of the chemical reaction. So in such a case, in the word equation there we only need to balance the chemical equation. So especially when we come to chemical equations more deeply, so we are using symbols or formulas or chemical formulas of compounds basically in order to uh, show what has happened in that particular chemical reaction. We are expressing the entire process by using symbols of elements and chemical formulas of compounds. So for that, when we express this chemical reaction in the form of a chemical equation, especially using the symbols and formulas, we need to uh, bother about law of conservation of mass. Here in law of conservation of mass, just we have studied in class 9. So in one activity we took certain chemicals as reactants and we mixed them together, we weighed them together. So after the chemical reaction, we close the particular conical flask. After the mixing, so the products form, and again we weighed the products. So the mass of the reactants as well as the products that were same. So this is what happened. So this fact, that means law of conservation of mass, so which states that the mass can neither be created nor be destroyed during a chemical reaction. So in that case we need to make sure that the same thing is happening when we write a balanced chemical equation. So what do you mean by balanced chemical equation? A balanced chemical equation means which obeys law of conservation of mass, which states that mass can neither be created nor be destroyed in a chemical reaction. Or we can say, in other words, the mass of the reactants, the sum of the mass of the reactants will be equal to the sum of the mass of the products. For example, you can again listen, sum of the mass of the reactant, say if it is 5 gram plus 5 gram, for example 10 gram, total mass of the reactants, that is 10 gram. Then for the, when you look at the other side, on the right hand side, the total mass of the products, that was should be, say if it is 8, so adding 2 gram, so 8 plus 2, 10 gram. So on the left hand side also you got 10 gram, on the right hand side also you got 10 gram. So this is for just an example. So this is how we write balanced chemical equation. So we need to follow the law of conservation of mass. This is more important here. According to law of conservation of mass, mass can neither be created nor be destroyed in a chemical reaction. So just what is then happening? So here you can see one example, iron. So just like we had already seen, burning of magnesium ribbon. So when you burn magnesium ribbon, what happens? Magnesium combines with oxygen so as to form magnesium oxide. So similarly here, so what is happening here? When you heat iron in the presence of water, that means in the form of steam, water in the form of steam. So what is happening? So it will react to give Fe3O4, ferrosulfuric oxide, plus hydrogen gas. So this is a chemical reaction. And similarly you can see over here, So magnesium, similarly, as we can see, magnesium reacts with oxygen so as to form magnesium oxide. So when you look at these two equations, so here you can see, look at iron, only one atom of iron is here on the left hand side. But when you look at the right hand side, there are three atoms of iron. Again, you can see hydrogen. Here two atoms of hydrogen, here also two atoms of hydrogen. Here oxygen only one atom, and here four atoms of oxygen are present. See, can you now say whether this is a balanced chemical equation? No. So we need to balance this chemical equation, then only it will be chemically correct. So for that, what we need to first, the first thing we need to do is that we need to make two boxes just like this, and we have to write LHS, left hand side, what we have got on the left hand side, that is iron plus water. Then on the right hand side, what we have got, Fe3O4, Fe3O4 and hydrogen, that is on the right hand side. So what is happening here on the right hand side? So that whatever the atoms what are present here, so that will remain here also, but there will be some rearrangement in the order. So again, so first one iron, we are writing it here, iron 1. On the right hand side, when we look at here, it is 3. So we are writing here 3. Then when you take next one, hydrogen, here on the left hand side there are two atoms of hydrogen, so that we are writing here as 2. Then while you move to the right hand side, there are also 2. Then about oxygen, here left hand side we have got only one atom of oxygen, and on the right hand side we have got four atoms of oxygen. So now let us try. So while you balance the chemical equation, so first you identify the compound, and the compound which is having larger number of atoms. So first, so we select oxygen. We identify a compound which containing large number of elements, and that is Fe3O4 here. And in that element, in that particular compound, the element with maximum number of atoms. So when you look at here you can see oxygen is having 4 atoms. But when you look at the left hand side, here only single atom. So what we have to do? See, in order to make on the left hand side 4, so we need to, we cannot write here 4 directly. So instead, what we need to do, I told you in the previous class, we need to add that value of 4 over here. So the equation now it will change to Fe plus 4H2O reacts to give Fe3O4 plus H2. Now oxygen is balanced. Number of oxygen atoms are balanced. Onto the left hand side, now it becomes 4, because this 4 will become common to both hydrogen and oxygen here also. This just we have rewritten that equation. Okay, now let us look which equation. So Fe, here are 3 atoms of Fe onto the right hand side. Then here also we need to make the iron, not to balance side, we need to write here 3. We cannot write here 3 because it's a metal atom. Metal atom do not form molecules. So we cannot even write here as subscripts. We are writing here as 3. Okay. So now look at 3 atoms of iron that is present here on the left hand side. Here also 3 atoms of iron. So now let us look at hydrogen. The remaining thing, 3 atoms of iron on the left hand side, 3 atoms on the right hand side. Then hydrogen. About oxygen we already balanced first. Then 4 and 4. Here also 4. Then now you look at what is about hydrogen. Here you need to look at, remember the previously learned portions, 4 into 8. how to calculate the number of atoms, especially when you get a molecule like this 4H2O. Here you need to multiply this 4 with this subscript 2. There are 4 into 2, 8 atoms of hydrogen is present. Now it is present in the left hand side. So in order to make that onto the right hand side also we need to make 8 atoms of hydrogen. Then only the equation will get balanced. So in order to do that, we can write that particular equation again. 3Fe plus 4H2O reacts to give Fe3O4 plus, in order to make hydrogen atoms 8, so we can write here, just we can multiply it with 4H2. Just you can write here 4H2. 4 into 2, 8. So 8 atoms of hydrogen. So now the equation has become balanced. Clear? So such an equation is known as balanced chemical equation. So it is very essential to balance the chemical equation because we need to follow the rule, law of conservation of mass. I hope it is clear. So if it is now we can just check whether these two equations, I mean this one and this one, both the left hand side and the right hand side is the balanced or not. For example, you can look here, magnesium and oxygen. Magnesium reacts with oxygen. When you heat it, reacts to form magnesium oxide. So here I have written the balanced equation. 2Mg plus O2 gives 2MgO. That's the balanced equation. Okay, 2 atoms of magnesium over here and 2 atoms of magnesium here also. Oxygen 2 atoms, here also 2 atoms. See, what is the atomic mass of magnesium? Atomic mass of magnesium, say now 24. That's why I am writing here 24. We are multiplying with 2 because there are 2 atoms of magnesium over here. So 2 into 24, you will get 48. 16. Atomic mass of oxygen is 16. So we are writing 16 over here, multiplying with 2 because O2, 2 atoms of oxygen. 16 into 2. So we will get 32. So when you add 48 plus 32, 48 plus 32, you will get 80. That's the total mass, 80U. Okay, 80U. That is the total mass of the reactants. Or the total mass of the reactant side. That means towards the left hand side of this arrow mark, that becomes 80U. So what on to the right hand side? So when you look at the MgO, 2MgO, this according to the balanced equation, this is the balanced equation, 2MgO. So 2 common for both magnesium and oxygen. So we will take 2 bracket 24 plus 16. So 24 plus 16 become 40. So 2 into 40 becomes 80. So this 2 is applicable for both magnesium and oxygen. So we need to take 2 as common. 2 we have to multiply with both 24 as well as 60. So you will get 24 plus 60 is 40. 2 into 40 you will get 80. So when you now look at on the left hand side, total mass of the reactant become 80U. And when you look at the right hand side, the total mass of the products also become 80U. So now we can say that the law of conservation of mass is established or it is followed. So the same thing here also you can look here. See, 3Fe plus 4H2O gives Fe3O4 plus 4H2. See, when you substitute the values of atomic mass of Fe, atomic mass of Fe is 56. 3 into 56. 3 into 56 plus 4 into H2O. H2O total atomic mass is 18. 4 into 18. If you write, it's okay. Or we are writing 4 into 2. Why I am writing here 2? Because 2 atoms of hydrogen. That's why I take it here 2. 4 into 2 we get 8. See, 4 into 16. 4 into 16. This 4 is applicable for oxygen also. 4 into 16. So you get 64. 4 into 16 you get 64. 4 into 2 you will get 8, 3 into 56 you will get 168. So 168 plus 8, 176 plus 64. Altogether you will get 240 towards the left hand side. When you look at the right hand side, Fe3O4 plus 4H2O. 3 into 56. 3, this 3 here, and atomic mass of iron, that is 56. 3 into 56 plus 16 into 4. 4 atoms of oxygen. So 4 into 16 or 16 into 4 plus 4 into 2. 2 atoms of hydrogen. 4 molecules of hydrogen molecule. So I am taking here 2. Then 3 into 56 you will get 168. 64 into 16 into 4 you will get 64. 4 into 2, 8. Altogether you will get 168 plus 64 plus 8, 72. You will get 240. See, when you look at here, on the right hand side, total mass of the product is 240, and here when you look at the left hand side, total mass of the reactant is also 240. So we can say that both the left hand side and the right hand side is balanced. So this is the meaning of balanced chemical equation. So I hope you understood all the video. Thank you for watching, and if you have got any doubt, you can clarify by asking me through WhatsApp. Okay, so practice few more questions for the same. Okay, study well and stay safe.